To begin our project, we went to Google Earth and took screenshots of each city.
In order to create the select city GUI, we made a primary GUI which just had one text box which said select city and 3 push buttons. In the M file, once you push these 3 push buttons, it calls the corresponding GUI city name to that function, which will open automatically once you click the button. And we saved the image earth.jpg into the background to make it more appealing to the eye.
To set up each individual GUI, we first put background images such as Honolulu beaches on to display in the background, and then proceeded to make axes corresponding to the image to set a grid line where we would take the image, read it, and set up these lines that would go every 10 columns and 10 rows until the end. And what those would do is it would set a full grid over the entire image so that when the user would click, we could take it using G input, and then we could take the coordinates of their click and we could set them into a certain range by first rounding down the X coordinate click and then doing the same with the Y coordinate click so that it would be at the start of a 10 by 10 grid, assuming every box in the grid is 10 by 10 rows. And then we set the left to X and the right would be 10 past that, so at the end of the box, and then we would set the bottom of that box is the Y coordinate, and then the top of that would be plus 10 because it's 10 rows above it. And then all together we could incorporate that into variables that would be holding the axes for the horizontal span and the vertical span represented by X and Y, with left, left, right, bottom, top, top, bottom representing one square individually, exactly where the user clicked. And then using fill, we would take that range and we would fill it in using RGB, red, green, blue, a particular spectrum of colors for the color we wanted for that exact square, here representing pink, and then we would put a hold on it so that every time you clicked it would go on the same axis. Then the axis that we put it on had to be the exact same dimensions as the image that we were using. So we filled in that axis, and then we would set the color of that axis to none so that it would be transparent and you could see our grid image.
So in order to create the bill of materials, we created the button with the callback of create BOM. And then in the M file, to code it, we use the callbacks from the static text QS5 to correspond with the total price of TS5. And in order to do this, we define the quantity as a string to double, and then we use that new string to define the quantity, and then we set that new quantity as the string of the handle. We had to repeat this 18 times for the 18 types of solar panels and wind turbines. And to the end, where we get to the total price, which also calculates, which is adding up all the prices of the model into one box, which we set with the handle as total price. In order to save as an image.png, we had to capture the image from the handle axis 1 as a frame and then convert that frame into an image, saving it with the command imwrite. And then to save the text, it's almost the same process, except we save it as a JPEG, then convert the JPEG into a matrix, and then write that as. In order to input the text file, We import the text as a matrix and then convert that matrix into an image using the label to RGB function. We save that as an image and then import that image into the handle of axis 1.
The average solar power per square meter was calculated using the solar power information provided in weather.mat. In order to calculate the potential solar energy per square, we multiplied the average available solar power per square meter by the square meters in a single square. The code counts the amount of solar panels placed onto the mesh grid originating from MathWorks. The program then proceeds to create an estimate of solar power produced by adding the solar power per square every time solar panels were placed into the grid.
To do our wind power estimate, we would go under each wind turbine and set up a click counter that would take the current value of the handle representing wind power estimate, and it started at 0, and this way every time you click, it would take whatever the current value was and it would add to that value the number of turbines, 4, times the power, 500 kilowatts per turbine per mile per hour of wind, and that times the wind in miles per hour for that particular city. That value was then converted back into a string and displayed in the text box so that the power per square, once you click on a square, will be added. Once the user selects load, it'll run through this, which will load the text file as a matrix, and the program will convert the matrix to an image using label to RGB, and that function will use imwrite to take it as a JPEG here, and then the program reprograms the axis by loading the image received from the text and setting it to the current axis, which is displayed with the same grid. So to run through the program, all you need to do is open the zip file and go down to selectacity.m, open that file and select run, which will open up the select city GUI, which gives you the option to pick between 3 cities. So if you go from there and you pick Honolulu, for example, what it'll do is it'll pop up a picture of Honolulu with a nice grid, nice background, you have all your panels. So you select a panel and you put it on the grid, and as you can see, the solar power estimate increases by clicking this. When we put on another one, put it right over here, and then the solar estimate has gone up, and this is on the bottom row is the wind turbines. You take a wind turbine, put that in, you see the wind power estimate has gone up, and it increases, and you can do this as much as you want, put in whichever boxes in each color, wind turbines on the bottom row, solar panels on the top two, and you fill it in with colors, and you select create bill of materials, and that'll show you the price per each material, and then here at the bottom it'll give you a total price. And then what you can do from there is you can save the image, and what that'll do is it'll put it right into your MATLAB folder. So when you hop back to your MATLAB folder, you see the images right here, and you open that up and it comes up in as a PDF file or a .png. It'll save as both, and then you can save as text as well, which will show you the text for your code that comes up in your MATLAB file, and it has all the numbers written out for your code saved as a text version. What you can do with that text version is now take it and push load previously saved text, and it'll pull it up with gray color, which is the closest match that we could find, and as you can see, you can just keep putting squares on it and they will still form in the grid, and once you've set more squares you can create bill of materials again, and it'll just update it. It'll also update the total price, the solar estimate, the wind estimate, everything works. And you can reset the GUI if you don't like it and you want to start over, and everything's blank again. You put on some new squares and all the values that started over, the solar updates, and you can push done to end.